Automation in a clinical laboratory. Automation is the mechanization of conventional mutual manual method. Here, analytical instruments performs many tests with less involvement of analyst. With the addition of new tests and as urgency of a new report increases, the workload of many laboratory also increases. When there is a large workload, manual experiments should be replaced by automated one with the use of auto analysis. This will help in dispatching the reports within the shorter times. The automation in the laboratory not only improves the standard of a laboratory but also decreases the number of staff member needed. The automation of a clinical laboratory helps in performing a large number of tests with low amount of samples. The automation methods requires less volume of reagent when compared to the manual procedure. The manual procedure are time consuming and make it difficult to handle a large number of samples if a specified time. Therefore, it may be difficult for biochemistry to dispatch the test result on time. All the above advantages of automation and the disadvantage of manual procedure made the scientists to introduce automation in 1950s. The productivity, quality, and safety have subsequently improved dramatically for those laboratories that have properly introduced and managed their automations. However, the automation increases the demands on the laboratory in many ways. The analytical instruments are burdened with an increase in the flow of reagents and specimens to be analyzed. The technologies and managers becomes a burden with managing the high throughput laboratory and processing all the information that results from the automated laboratory. Thus, there were sudden realization that there was a need in information technology to manage the automation processes. Similarly, output of analytical data can also cause a significant backup in data reduction and interpretations. Several manufacturers produces a variety of auto analysis. The manufacturer provides a detailed operational procedure for instrument they supply. The automated system generally incorporate mechanized versions of basic manual laboratory techniques and procedures. All the auto analysis have provisions for reagent placing, feeding the samples or standardization of known value, displacing of a result, and monitoring and printing of values through the recorded printer. The basic component of analysis are shown in the figure. Types of analysis: semi-automated analysis. This type of analysis were built in such a way that it should be read the optical density of solutions contained in the cuvette to produce the concentration of the substances. This type of analysis would be able to read the solution which has both sample and reagent mixed before. Since assay can done at a time using this type of analysis, setting the unit is automatic with regards to the wavelength, time, temperature, suitable for small laboratory which has a sample load of less than 25 per day or a 50 year batch analysis. In this type of instrument, the reagent mixture is mixed and fed automatically. A single reagent can store in the machine for at a time, so the batch of a particular chemistry test can be performed automatically. Random access analysis: more than one reagent can be stored in such a unit. The samples are kept in the machines and the computer is programmed to carry out any number of selected tests on individual samples. Types of analysis: it is very difficult to classify automated systems, even though the manufacturers focus on major processes in each automated system. In order to differentiate one system from the another, it is important to know the meaning of terms that are commonly used in the auto analyzer. Batch analysis: automated equipment, continuous flow analyzer, discrete analyzer, continuous flow analyzer, multi-channel analyzer, single channel analyzer, discrete analyzer, single channel analyzer, multi-channel analyzer, centrifuge analyzer. The single channel analyzer, continuous discontinuous reaction rate analyzer, multi-channel analyzer, large instrument, small instrument. The large instrument, discretionary, all tests are performed in each sample. Discretionary test selected for each sample. Batch analysis: many samples are processed for the analysis in the same analytical run. Sequential analysis: each test in the batch enters the analytical process one after another and the results are printed in the same order as they are fed. Continuous flow analysis: each sample in the batch flows one another in the sequence and it is subjected to same analytical reactions as other samples at the same time. In this type of analysis, each sample is separated from the following one with an air bubble. Discrete analysis, each sample has its own separate space. They are separated from one another and are tested in sequence. Single channel analysis, it is also known as a single test analysis. Each sample is analyzed by a single process, so the results of single parameter are produced. Multi-channel analysis, it is also called as a multi-test analysis. In this type, each sample is subjected to multi-analysis process and the set of test results are obtained. Random access analysis, any samples by a single to processing sample can be analyzed by an available processor in or out of the sequence with other specimen irrespective of the beginning order. There are several instruments mainly based on the principle, and the auto analysis are divided into floor and bench top models. The bench top analysis use a sequential batch and discrete type of analysis with the sample. The single channel continuous flow batch analyzer provides one result per analysis for each specimen at a rate of 50 to 60 specimen. Steps in automated system: sample identification, sample preparation, sample handling, sample transport and delivery, sample processing, reagent handling and delivery, chemical reactions, measuring, signal processing and microprocessing. Sample identification: the sample label is affixed to the sample collection tube. When blood is drawn, the sample on reaching the laboratory is recorded by the computerized procedure. After assessing, the sample undergoes the technical handling process, the process which requires physical removal of serum from the original tube. Secondary label bearing the same information of the original label must be affixed to the secondary tube. Barcoding: after a major advantages of automation of specimen identification has been introduced for barcoding technology into several of analytical systems that are now available in clinical laboratory. With this technology, a barcoding lab is placed onto the specimen container and is subsequently read by one or more barcode readers that have been placed at a key position in the analytical training. The resultant identification and other information are then transferred to and processed by the system software. Specimen preparation: the clotting of blood, centrifugations and transfer of serum causes delay in specimen preparation. To eliminate these problems, the use of whole blood for analysis, automation of specimen can be done. Specimen handling, transport, delivery: in most cases, the specimen presented to an automated analysis is serum. All cups or tubes containing the solution for analysis should be covered if assay is delayed. This is to prevent the evaporation of sample. Before the analysis, sample should be loaded on a loading zone. The loading zone of analyzer is the area in which the specimen are held in the instrument before they are analyzed. Specimen processing: the automation of analysis of analyte requires removal of interfering substances or proteins. Sample transport and delivery: the method of sample delivery and transport into the analyzer is major difference between the continuous flow and discrete system. In continuous flow, the sample is aspirated to the sample probe into the continuous reagent system, whereas in discrete analysis, the sample is aspirated into the sample probe and then delivered. Carry out between the sample can be avoided by setting an adequate flush to specimen ratio by incorporating the wash stations for the sample probe. Reagent handling and storage: reagents are stored in a plastic or glass container. They can be stored in laboratory refrigerators. If the assay is delayed, a refrigerator system can be introduced into the instrument as required. Reagent identification: label on reagent container includes information such as reagent identification, volume of content or number of tests for which the content of container can be used. The reagent bottle or barcoded wherever the instrument have barcoded readers. Reagent delivery: the liquid reagents are taken up and delivery to make up to mixing and then the reaction chamber by either pumping via tubes or by positive displacement syringe devices. There are various automated systems available commercial to analyze all blood, CSF, urine parameters. The demand for increased efficiency in healthcare prompted laboratory owners to provide the fast service at lower cost. It is necessary for the laboratory directors to plan which type of instrument should purchase, keeping it in mind that there should not be any compromises with the accuracy of the test. The system are selected to fit into the combination combination of automation, semi-automated, and manual mode of analysis. This is suited for any particular laboratory for the type of work and workload. Selection of auto analysis. It is very important to plan a laboratory setup. One who is going to set up a laboratory must survey the surrounding area where planning to open their laboratory. If the area compromises several doctors who are dependent on the laboratory report for the diagnosis and treatment of the patient, it is advisable to discuss them before starting the laboratory. It is also advisable to discuss with them for requiring laboratory tests which are helpful for them. In this competitive world, one has improved the laboratory standard by concentrating the cost efficiency, the time consumption, and accuracy of the laboratory reports. Before going to an automated laboratory, one has to work out the sample load and the time of and the type of the test one may get. Say if the sample load is under 10, then it may not advisable to go for the automated system in the beginning. Sample number exceeds 30 per day, then they may pick installing a semi-automated auto system in the laboratory.